All right, here is a limiting reactants problem. With your limiting reactants, the typical problem setup involves a chemical equation. As you see, this particular chemical equation has already been balanced for us, but don't be surprised if your teacher gives you a chemical equation that you have to balance and then begin to answer the actual problem. So in this case, um, it's given us 68.5 grams of carbon monoxide that reacts with 8.6 grams of hydrogen, which is the limiting reactant. And just a little background on limiting reactants. The limiting reactant of a chemical equation is going to be the one that limits the amount of the product we can produce. Okay, so let's get started. Again, as we've discussed previously, um, anytime we have a chemical equation and we're starting out with grams of an element, we always want to convert grams to moles, because as it relates to the chemical equation, let's highlight the coefficients. These coefficients tell us very important information. What this coefficient translates to in the chemical equation is that 2 moles of hydrogen will produce 1 mole, because we know that nothing here represents a 1 here. So 2 moles of hydrogen will produce 1 mole of CH3OH. And 1 mole of carbon monoxide will produce 1 mole of CH3OH. And because this is set up so that it gives us data about each individual element and how they react to produce a product, that information is provided in moles. We have to translate this information into moles so that we can then calculate whatever information it is that is we're being asked. And in this case, it's asking the limiting reactant. So I think it may be easy for me to begin to do this with you guys. So since we have grams is going to be our starting place. So we're going to go from grams to moles. Okay? Because that'll be our final stopping ground, and you'll see why in a second. Okay. So we're going to begin by converting grams to moles. So we have 68.5 grams of CO times our conversion fraction bar goes here. So we're starting out with grams. We know that our divisor has to be grams as well. Okay? And we know that to get 1 mole of compound carbon monoxide, we have to divide the grams of carbon monoxide by the molecular weight of carbon monoxide. And we know that oxygen is around 16, carbon's weight is around 12. We add the two together and we get 28. Okay. And let's do the math on that. And we get 2.446. Okay? And now we're going to do the same for the hydrogen. So we have 8.60 grams of H2. Do our conversion fraction here. We know we're going to go from grams to grams on the bottom so that these cancel out. We cancel out these up above. I'm going to do the same here. Grams of H2 to provide 1 mole of hydrogen. Okay, so if we're starting out with 8.6 grams of hydrogen and we're looking to get the moles of hydrogen, then just like the problem above, what we're looking to do is divide this grams by the molecular weight of this particular element. We know that the weight of hydrogen is 1. We have 2 here. 2 and 1 is 2. Okay? The math for that is as so. Okay, and this is moles of carbon monoxide, moles of H2. Okay? All right, so now that we have this, we want to build a ratio. Now, I've done this in a reverse order. If we look at our chemical equation, it's telling us the order in which these events are happening, which determines what goes on the top and the bottom of our mole to mole ratio. Okay, and as you might have already guessed, our mole to mole ratio, since we're comparing carbon monoxide and hydrogen, as it's set up here in our chemical equation, which one comes first? Our hydrogen atom or element. And so we're adding our hydrogen and then our carbon monoxide. So then the ratio becomes, as we see here, 2 moles of hydrogen reacts with 1 mole of carbon monoxide. Okay, so let's do that. And this is going to be our theoretical, right? Because we didn't calculate anything to determine this. This was solely provided by our chemical reaction. So theoretically, 2 moles of hydrogen will react with 1 mole of carbon monoxide. So let's set this up, and we're going to call this our theoretical ratio. And so that is 2 mole H2 per 1 mole CO. Okay, and we're going to box that in so as not to confuse you guys with this other jargon over here. Now, this is going to be our actual mole to mole ratio, okay, which we're going to later compare to our theoretical ratio. Okay, now again, we have our hydrogen at the bottom, our carbon monoxide at the top. We're going to need to flip those because per our chemical reaction, hydrogen comes first. So we're going to put 4.3. I'll do our actual in red. So let's say actual ratio. And this is our actual ratio because we've actually done work based on the information provided in our problem to calculate the exact amount of moles for each element. And so in this case, if we're using the same rule of going from hydrogen to carbon monoxide, we take 4.300 and we put that over 2.446, and so the units are there, H2 mole CO. And what we're going to do is right now, this is a little messy, right? We have 2.446 at the bottom, 4.3 of hydrogen at the top. We're going to take this divisor here and divide it into each one. Okay? And so that'll look something like this. If I move this over, I'll say divide by 2.446, divide by 2.446. And what happens is we end up with 1.757 over 1. And let's go ahead and tack on these so we don't get confused. Let's see if you guys are seeing this. Good job. So, and we do this so that we have something similar to our theoretical ratio. Because see, now we can easily compare the two the moment we break these up. Okay? So by using our divisor as a common denominator between the two, we clean it up to get 1.757 moles of hydrogen and 1 mole of carbon monoxide, right? And this is our actual. So let me go ahead and label this. This is our actual ratio. And now we're comparing the two. So let me box this in and further isolate them out so they pop out at you. So for our theoretical, looking solely at our chemical equation, for every 2 moles of hydrogen that reacts with 1 mole of carbon monoxide, we get 1 mole of CH3OH. But here, based on the numbers that are provided here, we only get 1.757 moles of hydrogen per 1 mole of carbon monoxide. Now, the carbon monoxide is just fine. We get what is expected from our theoretical. However, we don't get the 2 moles of hydrogen that is required to work or react with the 1 mole of carbon monoxide. We get 1.757. So in this case, what is our limiting reactant? Well, our limiting reactant in this case will be the hydrogen, because we do not get what is expected. So therefore, we will not get a pure product of CH3OH because we're limited here. Guys, see that? 2 to 1.757. We don't have nearly enough. Hydrogen is our limiting reactant.